Ever notice that when you open an old box of chords, they're all knotted up? Why does this happen, and what does it have to do with natural selection? In any species, all the individual animals are going to be slightly different than all of the others. While many of these differences won't have any meaningful effect on the animals, a few of them will give a benefit towards survival. These individuals are more likely to thrive and survive, and as a result, it will better their chances to reproduce with a mate. Now, some of the offspring of these individuals will carry those same advantages, and consequently, they will also better their chances at survival and reproduction. This process will repeat and repeat until all the animals carry that particular advantage. This is probably close to the description of evolution that you've heard in the past, but it fails in a few areas. The first thing to notice is that evolution and natural selection, strictly speaking, aren't the same thing, where evolution simply means a thing plus time equals a different thing. But because the evolution of species through the process of natural selection is a lot of words, we generally shorten that to either evolution or natural selection alone. Which brings us to the first of two concepts: the unrandom selection of random elements, where we have a group of varying elements, and associated with those elements is a process which discriminates some while choosing others. Let's call this preferred selection. Now, the second concept we need is just the opposite of the first: unpreferred selection. And by applying un to our previous definition, we have the unrandom selection of unrandom elements, or the random selection of like elements. Let's say we place a marble into a box, separated into squares. If we shake that box, the marble will randomly be placed into one of the squares. The randomness of this process makes it impossible to predict the location of the marble. All we do know is how likely that marble is to land in a particular box. We can change this likelihood by increasing or decreasing the number of boxes available. And we can further complicate things by adding a second marble, which creates an abundance of new configurations that can occur. As both the number of squares and number of marbles increases, our ability to predict a particular configuration is lost. There are two important observations to be made about this process. The first is the amount of randomness in different systems can be compared, simply by adding up the number of configurations available in each system. Secondly, when the amount of randomness is large enough, we can't predict which configuration the system will be in, but due to the large amount of configurations, we can discount the possibility of the system being in any special configuration. This is good news, because otherwise, all the air in the room you're in right now could just bundle up into any corner, and you would die. Now, by taking these two relatively simple ideas, we can explain a bunch of interesting and complex systems. Take a game of pickup sticks, for example. You begin the game by taking a bunch of identical sticks and tossing them onto the ground. The sticks serve as the elements, while the arrangement on the ground serves as a configuration. Due to the uncountable number of configurations, you're guaranteed a new game each and every time. This is just unpreferred selection. Next, each player takes turns removing sticks, trying not to disturb any of the other sticks in the process. If you're smart, the first sticks you'll remove are the ones on the edge of the pile, touching as few of the other sticks as possible. And as the game progresses, the inner sticks will become the outer sticks, and you will slowly work your way into the middle until all the sticks are removed. This strategy is a form of preferred selection, where the stick locations are the varying elements, and you're the selection process. But can we apply these same ideas to explain natural selection? Well, the role of preferred selection is pretty clear. The animals act as the varying elements, while the environment acts as the selection process by choosing the animals, who don't die. The role of unpreferred selection, however, is a little less obvious, and it comes through reproduction. You see, animals need to generate different traits to allow for the variation necessary for preferred selection to take place, and these variations are introduced through the DNA of animals. DNA is basically a large series of instructions on how to build a particular animal. When a new animal is conceived, it is given two sets of those instructions, one from the mother and one from the father. For each of the instructions, it needs only one of the two, so it chooses one randomly. The result is a new animal with a unique set of traits. So with the repetition of these two steps, survival and reproduction, we get natural selection. Which brings us back to the question at hand. Remember those chords in that box? As the box moves around, so do the chords, and as they do so, they explore a number of different configurations. Again, unpreferred selection. While most of these configurations do not have any effect on the chords, every once in a while a chord will move in just the right way to form a knot. And while you can move into a knot from random motions, it's very difficult to move out of them. So as time passes, the chords evolve to produce knots through unpreferred selection and preferred selection.